Okay, we are going to try to solve this rational function. We are going to attempt to understand the graph of it. So if we're going to graph something, we need to open up the xy plane and label it. That's x, that's y. Now we need to give ourselves the behavior of the function. So to understand the behavior of the function of a rational function, we can immediately begin with vertical asymptotes. Right? What is going to make me divide by 0 and what is not a 0 in my numerator, right? Because I need these to not be a removable discontinuity. So 10x squared is going to be 0 when x is equal to 0. Right? Is that going to make my numerator 0? Right, so I just plug this 0 that I know to be a 0 in my denominator into my numerator to see if it is also a 0, to see if they share a factor of x. Well, this is going to give me 0 minus 0 plus 2 gives me a 2. That's not 0. So x is equal to 0 gives me a 0 in my denominator, but not in my numerator. Therefore, I do have a vertical asymptote at 0. It is a non-removable discontinuity of this rational function, and I cannot cross this vertical line. So I'm going to give it dashed red to remind me that I can't do that. And at the bottom of this line, I'm going to put a little 2 in parentheses because the multiplicity of that, the multiplicity of this 0 in the denominator is 2, right? The factor x there occurs twice. So that has even multiplicity. This vertical asymptote right here has even multiplicity, and that is going to impact the shape of the graph later on. So let's continue. If we've talked about vertical asymptotes, let's now turn our attention to horizontal asymptotes. So this is going to dictate the end behavior of the function if one exists at all. It might not. So when we talk about horizontal asymptotes, we look at the degrees of the numerator and denominator. So let me get rid of these. The degree on top is 3. Right? It's a degree 3 polynomial. The degree on bottom is degree 2. So if I take a cubic and divide it by a quadratic, that's going to give me a line. It's going to give me 1x, right? This 3 minus 2 gives you 1. So I'm going to have polynomial-like behavior because the degree of the numerator is bigger than the degree of the denominator, and the polynomial-like behavior is going to be a straight line, and I can actually find that straight line by performing this division. What does r of x give me? So what is 3x cubed minus 5x plus 2 divided by 10x squared? So good news, we know how to divide polynomials. Let's take 3x cubed, oops, bad cube, cubed minus 5x plus 2 and divide into that 10x squared. So how do I go from 10x squared to 3x cubed? I need a 3, I need to get rid of my 10, and I need an extra x. And if I do this backwards, I get 3/10 x times 10x squared gives me 3x cubed. I then subtract that, and I'm left with minus 5x plus 2. And I can't perform this anymore, right? So my straight line is just the line 3/10 x. So if I graph that, and let's graph this in green, because I might cross this slant asymptote at some point. So it's the straight line with slope 3/10 and y-intercept 0. 3/10 x. In fact, let's answer that question now. Do I ever cross this slant asymptote? All right, so what I want to figure out, does my function ever return the value of that slant asymptote, right? is my function ever going to cross this? Because if they do, then they have the same xy point. So I set the two functions equal to each other. And I solve. So my function is 3x cubed minus 5x plus 2 divided by 10x squared. And I want to ask, does that equal 3/10 x? So I move the 10x squared to the other side. And I can simplify this. My right-hand side becomes the 10s cancel out. I'm left with the 3 and 3 x's. So I notice I can subtract that from both sides. I'm left with minus 5x plus 2 is equal to 0. That leaves me with 2 is equal to 5x, which leaves me x is equal to 2/5, right? Divide the 5 to the other side. So I actually do have a value here. 2/5 is equal to 0.4. So if I locate 0.4 on my graph, I cross my slant asymptote right there. So I know I have a point. Okay, now that the asymptotes are dealt with, now let's figure out where I cross my x-axis, right? Do I cross here? Do I cross there? Let's figure out where this function returns a 0. Oops. Made my entire x-axis disappear. There we go. So let's look at the zeros. What is going to make my function equal to 0? So my function is 3x cubed minus 5x plus 2 over 10x squared. I set that equal to 0. I move 10x squared to the other side. I get that 3x cubed minus 5x plus 2 is equal to 0. Right? Anytime a fraction is equal to 0, I know that the numerator is equal to 0. And this is a cubic, but I have a hint that x equals 1 is a 0. And let's see if that's true. If I plug 1 into this, I get 3 minus 5 plus 2. Okay, so that is a 0. So what this allows me to say is that I can write 3x cubed minus 5x plus 2 as x minus 1 times something else, right? I don't know what this polynomial is. I know it's going to be a degree 2 because here I have a degree 1. So I know that 1 plus 2 will give me this here degree 3. But I know that x minus 1 is a factor. I know this is present because I know that 1 gives me a 0. So because I know that this is here, I can just divide by it. 3x cubed minus 5x plus 2 divided by x minus 1 gives me that unknown polynomial. And again, I know how to divide polynomials, so let's figure out what this gives us. X minus 1 divided into 3x cubed minus 5x plus 2. So I need a 3x squared on top. I wrap that in parentheses, I subtract by it, and what am I left with? 0x squared minus 3x squared gives me 3x squared. I have minus 5x minus nothing, and plus 2 minus nothing. And now I do this again. I can go from x to 3x squared with another 3x. And if I do this backwards, 3x times x gives me the 3x squared by design. The 3x minus the 1 gives me a minus 3x. And if I subtract this, I have no x squareds. I have minus 5x plus 3x gives me minus 2x, and plus 2 minus nothing. And I do this one more time. To go from x to minus 2x, I need a minus 2. I'm left with a minus 2x plus a 2. And when I subtract that, I'm left with 0, which is good that I don't have any remainder, because now I'm able to write, let's go right here. Now I'm able to write 3x cubed minus 5x plus 2 as x minus 1 times something else, and that something else is what we got from the division. So 3x squared plus 3x minus 2. Right. So if I'm asking myself for the zeros or the roots of this polynomial, and I know that x minus 1 is a factor, so I know that 1 is going to be a root, I can figure out these other two. In fact, I may not get 2 from this, but it's a quadratic, and I know how to solve quadratics. Right? What is going to make this give me a 0? So you have a lot of different ways to do this. You could complete the square quadratic formula or try to factor this. It doesn't look like it's going to factor nicely, so I'm going to complete the square. And I like to complete my square with a leading coefficient of 1. So I'm going to pull out a 3 from everything. And divide by 3. Oops, why did I put that 3 back there? There we go. And now I complete the square, so I need my linear term, my constant there is a 1, and I need half of that, so that's 1/2, and then I need to add the square of that, so that's 1/4. So I have x squared plus x. I'm adding 1/4. I still have the minus 2/3, and because I added I added 1/4 to the left-hand side, I need to add it to the right-hand side. So effectively, this line and that line are the exact same thing. They just have an extra 1/4 on both sides. Now I can write this as x plus 1/2 squared. I still have this minus 2/3, and the 1/4 is still there as well, right? If you don't believe me, what is x plus 1/2 times x plus 1/2? X times x gives me x squared. I'll have a 1/2 x plus another 1/2 x to give me 1x. And the 1/2 times the 1/2 gives me that 1/4. So now that I can do this, I have that x plus 1/2 squared is equal to 1/4 plus 2/3 if I add the 2/3 to the other side. And I'm going to need a common denominator here. So let's take 12. How can I write 1/4 as something over 12? So I need to multiply top and bottom by 3. I have 3 over 12. How can I write 2/3 as something over 12? I need to multiply top and bottom by 4. So I have 8 over 12, which leaves me with 11/12. So x plus 1/2 squared is equal to 11/12. I take the square root and find that x plus 1/2 is equal to the square root of 11 over 12. Of course, with a plus or minus, because I took an even root. And now I subtract 1/2. X is equal to minus 1/2 plus or minus the square root of 11/12. So we're going to get 2 answers out of this. And if I approximate these 2 answers, I get about 0.46 and about minus 1.46. Like, let me check that other one. Yep. Okay, so I get those 2 answers. So now I know that 3x cubed minus 5x plus 2 has x minus 1 as a factor. It also has x minus 0.46. Oops, actually, no, I don't, because I don't want to round. So actually, I just want to list off my roots here. The zeros of our function r of x happen when x is equal to 1, about 0.46, and about minus 1.46. All right, so let's plot these. I have a 0 at 0.46 roughly, at 1, and at roughly minus 1.46. Okay, I think that we're ready to fill in the gaps. So let's start here. As I move to the left, I know that I need to either go up or I need to go down, right? Because I've got this vertical asymptote right here at x is equal to 0. Now I can't go down because then I would cross my slant asymptote. And I know I don't do that other than at that point right there. So I can't turn down, which means I have to turn up. Now I pass through this point. And I pass through that root, or that 0 that I knew that I had by solving for the zeros of my function. I have to turn around and pass through that 0 at 1. And now I never cross that green slant asymptote again. But that is my end behavior, so I get infinitely close to it. And now let's plot the left side of the graph, quadrants 2 and quadrants 3. So let's think about the multiplicity of this vertical asymptote. Right, this is a consequence of this 10x squared, and that has multiplicity 2. So it has even multiplicity, meaning that the behavior of my function on either side of that asymptote is going to be the same. So they're going to approach positive infinity on both sides. And I come down, I pass through my root, and I know I don't cross that green asymptote again, but I do get infinitely close to it. So this is a pretty decent idea of what the graph of this rational function is going to look like. All right, I hope you found this helpful.